بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه أجمعين. أما بعد. Mr. Chairman and dear brothers and sisters, first of all, I would like to thank the Kulliyah of Engineering of the International Islamic University of Malaysia for giving me this opportunity of being here today to present my work, which aimed on the valorization of household waste and camel dung via biogas production. In this work, I have the honor and the privilege to work with authors, with Dr. Maizerwan Mel from the Department of Biotechnology Engineering of the International Islamic University of Malaysia, and with Professor Dada Musa Belkhair, Dr. Drisi Habiba, and Dr. Labed Ibrahim from the Scientific Research Laboratory of the University Center of Taman Rasset, and also with Professor Bendrawa Abdelaziz from my university, which is the University of Sciences and Technology of Oran Mohammed Boudief. So, as mentioned, this work is aimed on the study of the potential of municipal solid waste and camel dung as feedstock for biogas production. So the media composition for biogas production was the main aim of this study. The experiment was as follows. 3 reactors with 2 liters capacity were set up at the laboratory to investigate the co-digestion or the effect of the co-digestion of the municipal solid waste and camel dung on biogas production quality and efficiency under similar conditions of temperature and pressure at 40 degrees Celsius and for 35 days. So the results that we had shows clearly that the mixing of the municipal solid waste and the camel dung contained well-balanced nutrients. And for microorganisms, for anaerobic microorganisms for biogas production, and gave us a proportion of methane about 57%, which was higher than the methane proportion produced from the digestion of the camel dung on its own, which was about 45% only. Introduction. To introduce this work, first of all, it's important to mention that the Algerian's economy increases. The reasons Algerian's economy increases, and this crisis is due to the fall of 70% of oil incomes, which made the country lose half than of its external receipts, and causing a significant deficit on its trade balance. The Algerian fossil fuel reserves will not last eternally, some 40 to 50 years, and the human activity causes an important change of the climate, which has actually important repercussions on the planet. So the need to find an alternative and renewable energy is becoming increasingly important for the sustainable development. The anaerobic digestion is widely applied in the whole world because of the increasing requests for renewable energies. So this study, the present study, is a laboratory scale experimental evaluation for biogas production from 3 different mixing under similar conditions of temperature and pressure at 40 degrees Celsius and for 35 days. Materials and method. As mentioned, the substrates were made up from the digestion of the organic fraction of municipal solid waste, the camel dung, and the co-digestion of both manners. The municipal solid waste was collected from the kitchen of the campus of Sartillemont in the town of Liège, and the camel dung was collected from Family Park Harry Malter, which is a Belgian park of animals located in Heusden in the province of Flandre Oriental, which this province is located at 180 kilometers of the city of Liège. Then the raw materials were transported to the laboratory of the Centre de Technologie Agronomique of Stray for pretreatment and analysis. The substrates had been through size reduction and were sampled just before injection to the digesters and daily during the experiment period. They were allowed to digest for 35 days at 40 degrees Celsius. As waste analysis is one of the most important steps in the anaerobic digestion process, knowing the general composition of the input material is also important and essential for calculating the amount and composition of biogas produced, as well as the amount of the energy contained in this biogas. In tables 1 and 2, it's shown extracts of the laboratory chart of the municipal solid waste and commandant primary analysis. In table 1, we see that the pH of the municipal solid waste before mixing had a pH of 3.9, a dry matter 14%, an organic matter of 98.6%, and a mineral matter about 1.4%. And in table 2, we see that the commandant had a pH of 7.3, a dry matter of 39%, an organic matter of 26.1%, and a mineral matter of 73.9%. The experiment was set up as a batch experiment with 2 liters of volume each. 2/3 of the 3 flasks were filled respectively with 600 grams of municipal solid waste, 600 grams of commandant, and 600 grams of equal parts of both manners. The substrates were mixed with tap water, leaving a head space about 800 milliliters. And the reactors were incubated in a conditioned room with controlled temperature, which this temperature was fixed in the range of 40 degrees Celsius. Biogas volume, methane proportion, and pH of samples were measured daily or once a day during the 35 days experiment. The numeric FEWI pH meter was used for pH measurements. The biogas volume was measured by water displacement system, and the methane proportion was measured by connecting a gas analyzer GA45 to the system. Also, each reactor was mixed daily for 180 degrees Celsius before sampling. Results and discussion. The biogas volume and the methane proportion for different media compositions are shown in figures 1 and 2. They represent the biogas, the volume of biogas produced expressed as a methane proportion. In figures 1 and 2, it's shown the average of methane proportion for the commandant and the municipal. It's shown that the average proportion of methane from the commandant and the municipal solid waste commandant media composition was about 45 and 57% respectively. This value obtained from this reactor, which is 57%, reflects the good operation of the anaerobic digestion of anaerobic digestion and agreed with the literature data and previous work of authors. Generally, a methane proportion of a methane percentage ranging between 50 and 80% remains acceptable for anaerobic digestion process. Methanogens work effectively. The lower methane percentage obtained from the lower yield was obtained from the municipal solid waste media composition. A possible explanation was the pH, or could be the pH and the fatty volatile acids. The pH of the municipal solid waste media composition was affected by the high volatile fatty acids content. The pH was about 7 after mixing with tap water and decreased to 4.9 because after the fatty volatile acid degradation started. Afterwards, the pH decreased again to 3.5, 3.9. And the pH of the Kamendang and the Kamendang municipal solid waste was about 7, was ranging between 7 and 8.1 during the experiment. During the experiment, the pH of the reactors affects the anaerobic digestion process and efficiency. Methanogens work effectively in a pH ranging between 6.5 and 8.2 with an optimum pH of 7. The pH varies because of many parameters such as the fatty volatile acids, the alkalinity of the system, the bicarbonate concentration, and the fraction of the CO2 produced during the experiment. To have a constant pH value, it's important to have a control on the relationship between the volatile fatty acids and the bicarbonate content in the substrate. For controlling pH, NaHCO3 and NaOH must be added to the continuous reactor during the startup period. Conclusion. The biological biogas production of organic fraction of municipal solid waste and Kamendang is better than that obtained from the Kamendang or municipal solid waste digestion on its own. Biogas production for co-digestion is much greater than thanks to the well-balanced nutrient content of this feedstock with methane proportion of 57%. The co-digestion process was set up through batch system and under low mixing conditions, which represents an energy saving. So, the anaerobic digestion of kitchen waste with camel manure is demonstrated to be an attractive method for environmental protection and economic energy savings for rural regions, but it is clear that with applying better equipment and adjustment of conditions, more reasonable results could be obtained. So, thank you so much for your attention and at your service for